All right, so we're into phase 3 of conservation biology. This is the first part. Uh, think about everything we've discussed in phase 1 and phase 2 and the different parts and components of those lectures. And what we're going to do at phase 3 is talk about how to put together a plan to try to avoid species extinction. Okay, so one of the first things we do is we jump back all the way to the beginning of the semester. And you guys remember these things called phylogenies? Oh yeah, those little trees, the cladograms, etc. Those play a big role in conservation biology. So anybody who thought, oh, I hate those trees, I don't want to use them, I don't like them, I don't understand them, I can ignore them because I'm going into this discipline, no, they're coming back. Okay? So the trees help us understand relationships, relatedness between species. So it helps us with prioritizing conservation. Which species are of most concern? Which species have unique traits? And what are the evolutionary connections? So we use that when we deal with conservation. What species are related to which ones? How do these things connect? That helps us can make certain decisions in conservation. So once we decide which species to preserve, we have to put together a plan. And as you were glancing at the IUCN Red List and the DNR site and those other things, there's conservation plans listed if we have one for a certain species. So what we do is we create a thing called a restoration project. You guys want to get deep into this? Take the environmental science course. That's one of your major projects. But we look at restoration projects. Okay, so here's a basic concept, very generalized. I just don't have time to get into detail in this semester. Restoration projects. They're projects that identify the root cause of a species status. Why is your species endangered? What's causing it? Go back to the list. Is it because of habitat issues? Is it because of pollution? Is it because of invasive? Odds are it's going to be a combination effect. But what is the primary cause? And as we mentioned, majority of species, it's a habitat issue. 85% of species are threatened with extinction because of habitat loss. And then how do we remediate it? So here's a simple example. Restore habitat. Yeah, hey, let's plant a prairie. Let's put some trees into the yard. Let's restore this. Can we clean it up? Can we rebuild the habitat? That's what conservation is all about, is restoring things and preserving things for future generations. All right, so that's the basics. And I'll show you the elements to what we call a recovery plan in just a second here. So, okay, so here's a case study. Peregrine falcon. Now, who doesn't like these things? Amazing birds. Back in the 70s, 60s, and 70s, DDT was used all over this country, and it caused a crash to their population. Did the same thing to the bald eagles and other big raptors. DDT was banned in 1972. In order to rebuild the population of peregrine falcons, we began to breed them in captivity in 1970. And we've rebuilt their populations, not to historic levels, but we're getting close. So here's a bird that was endangered, just like the bald eagle. And because of identifying the pollutant causing the problem, identifying the crash in the population, we put a plan in place to rebuild their populations, and we're doing a great job with it. So there are case study after case study after case study showing how to do this. So, okay, so recovery plans. There are 5 key elements to recovery plans here. Number 1 is you need to understand your population. So let's survey the population we're looking at. How big is it? This goes back to population ecology. How many males versus females? How many females of reproductive age? What's the reproductive strategy of your population? R, K, something else? Survivorship curves, type 1, type 2, type 3. All of that plays a role in understanding how quickly you can get your population to come back. Once you do that, you need to, once you know that information, okay, so once I know my population information, I can design my recovery plan to identify the main reason for the species status. So some plans I need to restore habitat because they just don't have it. That's those people planting trees. That's a pretty simple habitat restoration project. Plant trees, plant a prairie, etc. Others, it may be a reintroduction. Okay, we don't have wolves here. Can we bring wolves from somewhere else and reintroduce them to their original range? Illinois does not have wolves. We used to. Wolves are extinct, or they call them extirpated. Basically, they're eliminated from the state of Illinois. Could we bring wolves from Canada down here? Sure. Do we have the habitat for them, though? No. So your recovery plan has to identify and kind of target the main reason that the species is threatened or endangered. Once you have that plan put together, or I should say, as you're developing that plan, you have to factor in timeline and budget. So if I'm trying to restore a type 1 species that has a K strategy of reproduction, it's going to take a long time. I can't rebuild this population in 5 years. It might take 5 years to get one generation. So I have to have that knowledge to understand the timeline. And then the budget side of it. Is this a 30-year plan? Well, that's going to cost a lot more money than a 5-year plan. If I'm trying to rebuild bluegill populations, I can do that in about 5 years. If I'm rebuilding wolf populations, I need about 40 or 50 years. So knowing that species information, that life history, is critical for the timeline and budget process. Now, once you have your timeline, your budget, you start working towards your plan, you need to monitor. All right, so you're going to monitor. You're going to go out and you're going to check as often as possible. And usually you'll establish benchmarks, like every 3 years, every 5 years, maybe it's every season, depending on the species' life history. You can't do this on your own. You need help. This is where community groups come into the picture. This is where going to the bird banding station at Lincoln Land is monitoring species progress. This is where going out and volunteering and doing a prairie walk and all these other things that we can do. We need community support behind this to be able to do the monitoring. The scientists alone cannot even come close to doing this. There's too much manpower required to successfully monitor and track what's going on with the species. So you're keeping an eye on this. You're reassessing. You're making adjustments as we go along. So working in teams is absolutely essential. Working in groups, working with people is critical for the success of your recovery plan. You may have the best plan in the world and the most important thing to be done, but if you can't work with other people and communicate with other people, you're not going to get the public support you need. So keep that in mind. As a biologist, you have to be able to work with lots and lots of people, a big diversity of people. Okay, so then the last step in this conservation plan, in a recovery plan for anything, whether it is plant, animal, something you love, something that's cute and cuddly, or slimy and What is important is this right here. This is the most critical component of a recovery plan for any species. I don't care what animal or plant you're talking about, you have to educate the public. Why is this important? Why should we care about this? Consider the money for your recovery plan is probably coming from tax funding. If it's a state plan, a federal plan, it's all taxes. Why should people contribute to this? Why should people care about this? Why should people buy in and want to save this species? You have to talk to people. You have to educate them. A lot of it is starting with kids. Trying to educate a 75-year-old farmer that he needs to change his lifestyle and practices to conserve a salamander that lives on his property might be will be a very difficult task. But if you can start with kids and get them to buy in, then they go back and say, Mom, Dad, Grandma, Grandpa, we need to save this. They become your advocates. They're also going to be the ones who will be voting for supporting your programs as they get older. And most recovery plans, remember, they're not short projects. It's not like, oh, I only need a couple $100,000 for the next 2 years to bring back the species. You might need $100,000 for the next 30 years. Get the buy-in from the kids, younger generations. It's got a greater chance of success, especially, again, those plans that are long-term plans. So check this out. This is from one of my former students. She's a former Lincoln Land student. She moved over to UIS in their environmental science conservation area. She took the exact same courses you guys are taking. She took Bio 111, 112, environmental science, chemistry, etc. And this is part of her conservation biology course. It's a senior level course at UIS. So this is educational. Part of their course was to develop something educational about the problem that this invasive fish is causing. This is the Asian carp issue we talked about in earlier lectures. So this is great. It's a fantastic flyer, brochure, whatever we want to call it, that she put together to educate people about this. This is part of what you do as a conservation biologist, is you will create educational materials to get the public to recognize the importance. And a huge thing I will stress, and I do stress in the upper level courses, you have to speak different languages, call them languages. You have to be able to communicate to scientists, but you also have to communicate to the public. And most of the public doesn't understand the concepts that we're working with because they don't have a background in biology. It's not a criticism, it's just their backgrounds are in different areas. So when you talk to the public, you have to shift how you explain things so it relates to them and they understand it and they recognize the importance. So it is literally speaking a different language. It's public science versus scientific science, if you want to think of it that way. All right, so lots of examples out there. For those of you interested in the big picture or things outside of Illinois, check out this stuff. This is part of what I work with in Belize with the Jaguar program. We're looking at conservation of a species, but we have to look at the bigger picture. Can we save and conserve ecosystems? So the international organization Panthera is working with lots of countries in Central America on the Jaguar Corridor Initiative. And what they're identifying is they have to preserve large tracts of land across multiple countries for this species. Not just one little backyard or one park in a country, but thousands and thousands of acres and miles of habitat have to all be linked together. Because if you can conserve an ecosystem, you're going to save thousands of species that live in that ecosystem. So that's where a lot of biology conservation effort is going, is ecosystem conservation. All right, so if you're interested in the field, let me know. Happy to help you pursue a career in this area.